Good afternoon to all of the students. Today we will discuss about the periodic classification of element. In this we will see element and their classifications. We will talk about the Dobereiner traits and Newland law of octaves and Mendeleev periodic table and modern periodic table. These things we are using, this element we are using in day-to-day life. So we will discuss about these things. Now first of all, you just look what are the type of the matter. You know solid, liquid as gas. And what are the types of the elements. The element you know, carbon, sodium, hydrogen, all these things. There are different type of the carbon. The smallest particle of matter that you know very well. And what is the difference between molecule of element and compound? The compound and molecule, there are different things are there. In a compound, the two element combines, and in an element, a single element is there. You know, in day-to-day life, in present day, there are 118 elements are there. And day by day, all the elements are discovering every day, every times. There, we can say few of the elements are natural and few of the elements are man-made material, man-made elements are there. So we will discuss about from the 1800. Year 1800, there 30 element was there during Dobereiner trait times. That was in 1817. The German scientist Dobereiner, he suggested that elements are related to atomic mass. According to atomic mass, the Dobereiner trait was related. Means whatever the element are related to according to atomic mass. Means if you will take the three elements, and the three elements, the first and third element of the mean, it will show the middle of that atomic mass. According to the Dobereiner trait. Means he arranged the triad. Triad means he arranged the three elements of the atomic mass. And shown the middle element is the mean, arithmetic mean of the first and third. Now the middle element is the arithmetic mean of the first and third. These things he given the name as a Dobereiner trait. Now we will discuss about the triad lithium, sodium and potassiums. Lithium is 6.9 and you just see sodium is 23. Now the sodium they given how 6.9 plus 39.1. If you will divide, you will get the element of the sodium, that is 23. So they given. So just see lithium 6.9, sodium 23. They given, and the potassium 39.1. So here when we will add lithium and potassium 6.9 and 39.1 and you will divide by 2, you will get the arithmetic mean of the sodium, that is 23. Sodium is 23 and arithmetic mean of the lithium and potassium is also the same. He told about this means. Atomic mass of the triad means the arithmetic mean of the middle element is the first and third one of the middle part. As example of the calcium, strontium and they are telling barium, Sr. Calcium, strontium and the barium. The calcium weight is 40.9, barium is 17.37.3 and the strontium, that is 88.7. So when you will add the weight of the calcium and strontium, when you will add the weight of the calcium and the barium, so you will get the strontium weight. You will get the weight of the strontium. This according to the Dobereiner trait. This according to the Dobereiner trait. But Dobereiner trait is not exactly correct every place. In the case of the magnesium, calcium and strontium, you can identify which is the property of the Dobereiner traits. Now magnesium is 23, 24 and strontium is 87. When you will add, you will observe that how much the weight. It is nearly, just see how much you will get the weight of the 60. Dividing by 2, that is 87 and 24, nearly it is 130, and when you will divide by 2, so you will get the weight of the 60, but here calcium was 40, so we can't say as a magnesium, calcium and strontium is coming in the Dobereiner trait. In the second case of the sulfur and thallium, that is 32 and 127, 32 and 127 you will divide, so you will get 129, 129, 169, that is nearly, you will add 127 and 32, it is nearly 159 something. 159 you will divide by 2, so you will get around 159 divided by 2, it is nearly 75 something or 65 something. So 65 and 79 we can't say as a property related to the Dobereiner trait. We can't say as a Dobereiner trait. But in the case of the beryllium, magnesium and calcium, beryllium is around 40, beryllium 9 and calcium is 40. It is coming 49 and you will divide by 2, it is nearly magnesium. So some of the places Dobereiner trait is coming. We have to identify the third one. Third one we can say as a Dobereiner trait. But in the case of the Newland law of octave, the Newland law of octave, during Newland law of octave, some of the more element has been discovered. The Newland law of octave he told about 1866. He arranged the 8 element and shown that every first and 8 element has a similar property. He told every 8 element, first and 8 element has a similar property. He told like an Indian musical system type, that is sa re ga ma pa dha ni sa, like this way. Or we can say musical do, re, mi, fa, sol, la, ti, like this way, the 7 notes of the Western music and 7 notes of the Indian music. So every first and the 8th has a chemical property same of the atomic mass. Here hydrogen, fluorine, lithium, sodium, beryllium, magnesium, like this way. But some of the places chlorine, cobalt and nickel you will observe. He told according this one. But magnesium shows the similarity to beryllium. In the case of the magnesium and the beryllium, you will observe they have the chemical property. Boron and aluminium, the chemical property. That means according to the first and 8th of the every object, of the every element, it means they are telling us in the same one. But some of the places metal and non-metal came together, means the metal property and non-metal get the similarity. That was a wrong thing. That was the wrong thing. Because of this, the Newland law of octave also failed. Because of this also, Newland octave also failed. Then coming Mendeleev periodic table. Mendeleev periodic table, it came in 1869 and Newland was it in 1866, means they are after few of the years, 3 years after. Mendeleev arranged according to the tables. He given a new systems fully according to the table. 1869 to 1872 he made a periodic table. This is the most important concept, and this concept also we are using in the modern periodic table. In this time, Mendeleev periodic time, there was 63 element was there. In the Dobereine time trade, you will observe that was not so much of the element. It was 30 only they are telling. But in the Mendeleev periodic table, there are nearly 63 element was there. He arranged in all the element in an increasing order. He arranged all the element in a increasing order of the metal and non-metal. This is the main concept. But on the basis of the Mendeleev periodic table, we state that there are 8 group was there. Just see, group 1, group 2, group 3 in the modern periodic table he struggled, and he give the concept of the 63 tables. But he know also very well some of the every time the new element also getting. So he left the space also for the new element. He left the few of the space for the new element also. So you just see group 1 RO, R2O, group 2 RO, group 3 R2O3, like this way. Group 4, group 4 also you will observe RO2, RH4, RH3, group 5, O5, group 6 and group 7 and group 8, that is RO4. You will observe that in the group 1. In the group 1 first hydrogen is coming, that is 1, and then lithium was 7, 23 sodium. Now if you will see the first and the third, means some of the properties matching of the Dobereine also and Newland also. Some of the property is matching of the Newland also and Dobereine also in the Newland and octave. A Newland law of octave and the Dobereine trade. This both the property has been arranged in the is getting in the Dobereine trade also. This both the property we are getting in the Dobereine trade also. So he arranged according to the Newland law of octave and Dobereine trade also. So if you will see the concept, 11 plus 7 lithium and the boron, you will add, that is 18. 18 divided by 2, that is 9. That is the same property like in a beryllium. Like this kind of the concept, you will see boron and the nitrogen, that is 11, 14, and calcium is 12. 11 plus 14, it is nearly 25. Divided by 2, 12.5. That is same like in a carbon, 12. So he struggled so much, and concept, he did the concept. And he given the name. The periodic table are called as in a group. The column, you are looking, column group 1, group 2, group 3, group 4. This group we are telling as in a, this period, horizontal, vertical you are looking as in a group. Vertical column you are looking as in a, this is a group, and the horizontal row we are telling as in a period. The horizontal row we are telling as in a period. So there is a general formula of the compound also given in this RO2, RO3 in the group, nearly you look. Down group 1, that is RO, R2O, group 2 ROO, like this way, R2O3 in the case of the group 3, etc. in the upper order. Above the group, in the group 1, and then you will observe R2O, group 2, that is RO. Like this way he made the arrangement. Now introduction to scientist Dmitri Mendeleev. He was a professor, St. Petersburg University. In 18, the birth and the death he given 1834 to 1907. He made a separate card, was known as an element. He made a separate card that we are telling as an element showing atomic mass. That's showing a atomic mass that you can look, and property also in all this thing in the Dobereine trade. In the Mendeleev periodic table of the element, which resulted in the invention of the periodic table, and because of this periodic table has been made. So there are some vertical column in the periodic table. You will observe there are some vertical column. You will see are group 1, group 2, group 3 of this, and the atomic mass or atomic masses also you will see in predicted. As example, H equal to 1, lithium equal to 7, barium equal to 9.7. He predicted atomic mass along with the groups and period, and according to group and period he predicted mass also. Due to uncertainty in the name of the element, a question mark was added. Means he does not know some of the element, so he put it a question mark. Now before the symbol in the Mendeleev periodic tables, means before in Mendeleev symbol, as you will look CE 140 question mark, LA 180 question mark. This is the uncertain. He does not know. He put it a question mark with what are such symbol. This today we are telling as a symbols. Means he does not know what kind of the element and what kind of the symbol. So he put it a question mark and told this element has a something 140 masses. So tomorrow we will continue about the merit of Mendeleev periodic tables.